All right, welcome back, everybody. So this week I have Mike, the chemist from Envirolack. I'm always excited when I get to talk to chemists. I always learn a lot. It always makes me better. So thanks for coming on and being willing to discuss some of the things that come up with Waterbase and how you guys are dealing with them.
Yeah, you're welcome. No problem. It's my pleasure.
All right, so kind of give us just a brief background of your background in terms of, have you done solvent or just water? Like, what's your background in coatings in terms of formulating?
I've done a little bit of everything. I spent a lot of years at a much larger company doing bench chemistry through lab management, and I was a technical director there as well. So I've had a touch on every piece of chemistry and for wood coatings, from straight nitrocellulose to pre-cat, post-cat, 2-pack polyurethane, 3-component polyesters, 100% UVs, solvent UVs, water UVs, and of course the water-based with them. But now just focused entirely on water-based.
Awesome, great. All right, so one of the things that I want to ask, and it's sort of a loaded question, I know, but the question out there for a lot of guys, and I'm going to ask kind of a lot of levels of questions, and I'll let you unpack them how you want to, but is water as good as solvent? All right. And then also, as a formulator, I've talked to other chemists, and I want to kind of get your viewpoint on that a lot of times with solvent finishes, certain parts have to equal certain parts. So if you have X amount of this, you have to have X amount of that. I've been told with water-based, it's a little bit more fluid. It's not as an exact science, and that's why some of the issues that we're going to probably discuss in here kind of come up. So as a formulator, what is your take on that? Water versus solvent. Have we come to a point to where it's a non-factor at this point?
I don't think it's a non-factor. The biggest hurdle you have to overcome with water-based is the fact that it's being put into water. And water has a very high surface tension compared to all these regular solvents that we're used to. It can be 2 to 3 times the surface tension of a conventional solvent like toluene or acetone or ethanol or something like that. So that's the biggest thing that needs to get overcome in waterborne, is the fact that they inherently don't really want to flow on their own. From a performance standpoint, I think, yeah, there's definitely, if you look at what I would call traditional solvent-based stuff, if you're looking at a pre-cat or a nitro lacquer, anything out there water-based is going to outperform that. I mean, those things kind of tend to be very entry-level products. When you get into 2-component materials, you're talking either post-cat lacquer or conversion varnish. The goal of water-based material is in a 1-component system to achieve that kind of performance. In a 2-component system, I think right now there's water-based that will perform on par with anything out there solvent. I think the trick is getting it at a DIY level, where it's some guy who's just coming into a shop and wants to try, a simple water-based product, can spray it and have very good results like you might be used to with solvent-based. You mentioned that the solvent-based material, everything has to be kind of in a certain ratio, and the water-based, you've got that flexibility. Well, the reason for that is all those solvent-based are really 2-component reactions. So if you're talking about a pre-cat or a post-cat, like any kind of reactive amino coating, those are going to have, you do have to have your alkyd binder with either your urea resin or your melamine formaldehyde resin in there at a certain ratio. Then you have to add your acid catalyst, to maintain that 2-component cross-linking reaction. With a lot of the water-based stuff, they say it's a little bit more flexible because the resins generally come in that we're looking at right now. We're looking at using 1-component materials. So yeah, you could mix and match resins in a lot of cases, but these things don't always want to go together.
Yeah.
So that tends to be the art form there, of finding what works together well. Without causing any undue problems.
Yeah, and the reason what I've talked with other companies like Renner and CIC and talking to those guys, we still are learning and we're perfecting water-based. Would you agree with that comment?
Absolutely. I mean, solvent-based technology has been around, forever. I mean, and even still, there have been improvements in the last 15 or 20 years, even to conventional solvent stuff like like a conversion varnish or a catalyzed lacquer. What you tend to see is guys in low VOC markets where they have to deal with, acetone or PCBTF solvents. They have very limited, range of VOC solvents. So all these regulated materials in solvent-based, you see a lot of struggles with that because it's a newer problem. Even then, the problem's been around since the 80s. It's not a big shock. So yeah, moving into water, what you've got to do is you've got a whole chain now of suppliers that have to adapt their technology from making a solvent-borne product to then dispersing it or emulsifying it into water. So you've got that technology growth from the raw material suppliers getting slowly transferred into the paint manufacturers. So the key is really trying to be on the lookout for the newest iterations of resins that have come out, or any new technologies or new chemistries that might be coming down the pipe, because those could really offer a step change in the material that's out there right now.
Yeah, and I've seen that recently with some of the companies that I've worked with. It's some of these new resins are, it's getting better and better. With your resin manufacturers, are you saying, semi new stuff, or are you guys kind of like, you've got your products and you're kind of like just kind of tweaking them as you go? What kind of new development are you guys continually looking at from, your resin suppliers?
Oh yeah, we're always looking at what may be available for us as a large improvement over what we've got right now. We started off. We kind of, you can't just keep changing the product, or else you're not going to make it anymore.
Right, absolutely.
But we found ourselves a core set of resins that we're happy with. But yeah, we definitely have a pile more material in the coming shoot. To look at improved hardness, certainly early hardness. When guys that are used to using a solvent base, they get that crisp hardness very, very fast. Just trying to be able to transition people from solvent to water. Unfortunately, you can't always just tell them, yeah, it's going to be different. Sometimes you just want it to be the same.
Right.
So that's some of the transition there for us. But we always have new products, not necessarily new products, or maybe new resins that we're trying out in our existing products to see if we can make improvements on them.
Great. Awesome. All right. So let's go back just for a second. You mentioned this a little while back about, someone that's coming from solvent to water and the surface tension issue, because I want to bring this up because I think it's very important for people to hear this, because out there on social media, everyone, and I've been guilty of it, and I've kind of been showing the water-based stuff as a side, but a lot of guys, a lot of solvent materials, like they come off the gun, they look like a sheet of glass. All right. The water stuff, some resins will do that. Others, it takes a little while for it to flow out. Can you just talk a little bit about that? Because I think people are confused about, how this works. Because like I said, I've shot a lot of different water base, and some of them you're like, oh my gosh, that looks terrible. It's orange peely. I've got to fix my gun. I got to fix this. Can you touch on that for a little bit?
Yeah, and depending on the resin that's being used, like you said, it could be depending on the temperature that's being applied, could depend on the material that is being applied on top of. You could have a different wet film appearance from product to product. Yeah. You definitely want to let it dry down and make sure there's not any issues. Especially if you're looking at anything that's higher than the higher gloss material, not necessarily full sheen. But there is a natural kind of ripple just because you're dealing with this water in there, and until some of that water escapes and the surface tension of the resin and the coalescing solvents and our additives can take over, you're really not going to. It's unlikely, unless you put a very heavy film, that you're going to get a glass-like surface. And if you do have that, it may not even dry down to the glass smooth surface. It can be deceptive that way as well.
Sure. Yeah, I just wanted to make that a point, because a lot of guys are confused out there, I feel like, on how water base flows out. And like you said, and I'm glad you brought that up too as well, that it depends on the resin. That's one of the things. I was visiting another company doing some training with them, and I specifically asked that question. I was like, why does this product of you guys, it looks, awesome off the gun in this one? And he talks about, well, it's just a difference in the resin and the flow additives and everything that's in the material, but the end result was beautiful for both of them.
Yeah. Yeah, no, it's very true, and a lot of it is just, I tend to look at what the finished film is going to look like, just because I understand that as this material dries down, it's going to go through different stages.
Yeah.
As long as I don't create any kind of Bernard cells or something like film defect, I'm going to allow that material to just flow out naturally to see how it's coming down.
Yeah.
We use a lot of polyurethane resins as opposed to acrylics. They tend to have a better natural flow in the water-based than acrylics and solvent-based are very stable, very, very common, and they've been used for a very long time. So they look great. But in the water-based, the acrylic resin range tends to have a little bit poorer flow than the polyurethanes.
Yeah, I've noticed that. Interesting enough, like I actually personally, I don't have anything against the acrylics. I think that they can look just as nice, but I've tended more as I've shot more polyurethanes. I was like, I don't know. I like the polyurethanes in the water base a lot better.
A little more forgiving.
Yeah, they are. They're easier to use. You're absolutely right. Glad you brought that up. All right, so let's talk about a viscosity thing. So that's another confusion that people have out there, because you have, some of your big boys that have sort of what I would consider older, really generation acrylic type technology, and they're very thin. And then we have Italian, type coatings that are a lot thicker, and they use the word thixotropic for those, where, as they're going through, they thin and then they come back out. So how do your coatings, are they thixotropic in nature? Because obviously you have a very heavy viscosity. And what is the reason for a higher viscous material versus a thinner material? Is there advantages or disadvantages between the two?
Okay, well that's a good couple of questions there.
Yeah,
I guess
sorry.
Pick down the first part to start with. Our coatings tend to be on the higher viscosity side, 1,000 centipoise to 2,000 centipoise, which, I mean, unless you're using a Zon 4 or a Zon 5, it's not even going to go through it.
Right.
Depending how you're spraying, we would recommend putting a little bit of water in there if you're putting it through a conventional like cup gun, just because the cup guns don't have the pump to push that fluid along. Like you said, that you've got older, thinner materials. That's coming from the school of this is going to work the same way as your solvent base does. Instead of necessarily finding a right balance of resins and additives, they've just said, well, we're just going to reduce the product so it's thin enough, viscosity-wise, that the material flows out well in that stage. But then you have problems with hang and sag, and you can even have the convection current problems in material having cell structures in the finished surface that you didn't expect because of that low viscosity. The higher viscosity materials, they just need to have a better balance, whether it's the resin or the low shear and the high shear thickeners. Certainly for the standpoint of like can stability, it's easier to send out a higher viscous material. It doesn't settle. The matting agents have a lower tendency to go to the bottom of the pail. Requires a little bit less stirring. I can see a can of our PR170 primer there in the frame.
Yeah.
That material is thick, but it's also very high solids, and it really doesn't settle. Sitting in the can unless it's sat for years. So you get the advantage, certainly in can stability, a high rheology, high viscosity. There's not a real drawback to flow in high viscosity unless you're dealing with very porous substrates, walnut and oak, where you've got that deep open grain, where you're looking for the material to kind of soak into that grain and not leave a sharp point at the end of those grains. That's always been a problem with water as well. That kind of leads into another surface tension problem, more so than just a viscosity problem. But no, there's no real reason why you would specifically select low visc material. I could take a low viscosity material and turn it into something high viscosity. The issue then probably becomes air entrapment. If you've ever sprayed something that's very thick, if you're putting it through an air mix or an air assist airless, you can have some issues with the air entrapment because of the viscosity. Like I said, it's kind of a two-part question there. I think I answered most of it.
No, yeah. And can you touch on this, because a lot of guys are confused also on the fact that just because it's thick doesn't necessarily mean it's going to hang as well. So can you touch on that? Just because you have a heavy viscosity doesn't mean it's going to have vertical hang, because there's a lot of guys that are using some of the trim paints and stuff out there, and they're like, I can't hang this stuff, and it's like, well, it wasn't designed. Just because it's thick doesn't mean that you get better vertical hang.
Sure. And then I guess this may have been part of where you wanted to go with your first question, is the difference between either viscosity and rheology. So the viscosity, just in the general, if you're saying it's thick, it's viscous as a fluid, it's heavy. Like honey is very viscous, and it's a viscous Newtonian flow fluid. Whereas you have most paints, they tend to be more pseudoplastic, where they're going to have a reaction to the amount of shear. So let's take a paint, for example, that's high viscosity but doesn't have any thixotropy or any shear stability. It's going to pump through your pump, and it gets sheared down. As it goes through that pump, the viscosity is actually dropping. Just like if you take something, you start stirring it, you'll notice the visc might break down. It gets a little thinner when you start stirring it. So that rheology, that thixotropy is breaking down. The intent is for when that material goes out is to hit the panel and then to set back up, and for that rheology to rebound. So you can start with a material that's medium high viscosity. It shears down as it goes through your pump, and then you have that rebound to get the hang in a vertical application. And that's the thixotropy when people talk about it. Just because something is thick doesn't necessarily mean it's going to have that rebound of viscosity to hang. Now, there's a variety of different tools you have, certainly in the water-based material side, to approach each of these problems differently. We have a specialty product that's made specifically for hangline chairs. It's an acrylic, but it's very, very high build. I mean, you can easily achieve 12 plus mils of hang in what is relatively thin material. So, the control specifically over what might be the thickness viscosity versus the ability of something to hang is quite separate, certainly in a water-based material rather than what you might see in solvent-based, although the concepts are very similar. In solvent-based, be a lot of clay-type thickeners that just go in and spray and hit the board and hang well. The real trick is getting the product to have good anti-sag properties without impacting the overall appearance and flow. Because these things that make it want to sit still obviously want to prevent it from flowing out. So that balance tends to be more important than just whether you've got a thick product versus something that sags.
Which is kind of where I want to go. And I've got a panel here, and I'm not going to tell the manufacturer, but so one of the things that I've discussed with some other companies is when you're talking about you're putting some type of pigment in a resin that's designed to be a clear. And when you shoot it on a vertical surface, this seems to be the biggest hang up that I've found with water-based is vertical application. And what'll happen is it's been described to me as, I think the term is flocculating, where the pigment wants to start separating as it's drying from the clear that it's in on a vertical surface. I have a picture. I don't know if you can see this or not, but I call it the cottage cheese effect. I don't know. Can you see that?
It kind of looks like orange peel from here. I can't really see.
Yeah. So it looks like orange peel, but the surface is like completely smooth. Do you run into that, or what is your take on that?
That is, well, I mean, that's a problem, like especially in straight vertical application. You need to control your film builds. I mean, I don't know how much material is applied there. Tends to be worse if you apply a heavier coat.
Yep.
because what you're seeing is you're almost seeing a sheeting where you've got like an under sag. Now you're saying you can see it, especially in pigmented materials, and that just may just be highlighting it because it is pigmented. It would definitely happen in a clear coat as well. Just the clear coat's not as obvious. So in the case of a pigmented finish, when people talk about flocculating, usually they're talking about the pigments themselves coming to the surface of the finish at different rates. So flooding or floating. So if you have color flooding, you can do rub up tests. You can see that color change. If it's a multiple colorant system. As far as the vertical application, it's a bit of a trick, whether it's a matter of applying a thinner coat multiple times. It's a matter of finding the right balance between, again, the viscosity and the thixotropy, but then you've gone and thrown a little kink in and added tinters and pigments, and those pigments are generally dispersed into water with the use of a lot of surfactant, and that surfactant then goes and it breaks the backbone of the material that we've used to create the viscosity profile that we prefer. So, if it is something that you're tinting on the side, it can change drastically with the addition of viscosity. Can change drastically with the addition of tints.
Yeah. But I just wanted to bring that up because, a lot of guys complain about that, especially with the thinner materials. And can you talk about this? Because I've had a lot of guys talk about what you're kind of talking about in terms of, putting a lighter coat on. But one of the things that I've noticed with Waterbase, it's like a fine kind of balance. It's like you can't put too little on because it's not going to flow out, but then you can't put it on too heavy. And it's really difficult and in a hand spray application, to be honest with you, to get that right every single time. What do you have any suggestions for that?
Well, I think primarily that's why we've tended to lean on the higher viscosity side for these materials. We know that they're going to flow well, and giving that higher viscosity initially gives people a little bit more freedom, whether they're adding a little bit of reducer or whether they're adding some pigment to it, to not as greatly impact the rheology profile or the viscosity profile of the material, when they go to do a vertical application or even the edge of a flat application spray.
Yeah.
So part of the reason that we have targeted a higher viscosity is, again, it just seems to be a little more forgiving, versus something that's already, water thin.
Right. Yeah. All right. Great. All right. So let's talk about the other issue that comes up a lot, and you hit on it a little bit earlier, but I'm not sure if I really completely understand this right, because a lot of guys call it micro foam or micro bubbles, and then I've heard other guys call it like macro bubbles or something that gets trapped in the film. What is the correct terminology of that? When you spray something out and you have, you see all these bubbles, and sometimes they flow out and some they don't. What is the correct term for that?
Generally speaking, macro foam will be any foam that you can visually see on the surface of your material, and microfoam is material that is foam that's trapped inside the liquid film. Microfoam and macrofoam are dealt with in two separate but similar ways. Microfoam is actually an issue, even on the production side. When we're making the material, we're trying not to incorporate foam into the liquid, as we can, because it's going under high-speed mixers. Unfortunately, it's got all these nice flow additives in it, but these flow additives will stabilize foam. So you end up fighting them with defoamers, and so there's chemical defoamers that we use that go in and are intended to break these bubbles apart. Certainly for macro foam, these work very well. For microfoam and water-based, it does a bit of a trick finding the right defoamer. The other side of it then becomes all of this can be impacted by application as well. If you've got material that doesn't have enough atomizing air, it won't have the pressure either through the tip on an air assist, or it may not have enough air pressure behind it to fully break apart that paint in the spray fan to get those bubbles, to get those paint droplets, small enough that when they apply evenly, and they aren't like a gob of paint that's actually got a drop of air in it already, that you're just basically putting air into your layer of finish. Yeah, that's in a short. I mean, I guess that's macrofoam and microfoam. I mean, but it's a huge part of water-based products, just because the water tends to stabilize foam so easily because it's high surface.
Yeah, and we talked earlier with Stefan about, the biggest, it seems like the biggest issue is air assist, which tends to be cause the most problems. Would you kind of agree with that?
I think just the nature of how an air assist pump works, it certainly makes it more difficult, but everybody's using it, so you have to have a solution for that.
Yeah. Well, and I mean, I'll be honest with you, some companies don't. I know some that's like, you just can't shoot their product out of air assist. It just doesn't work.
Yeah. Yeah. Well, then they're not going to be able to sell to any large customers. I mean, because
it's not an option for us there.
Yeah. No, I hear you, man. I'm very curious, and very, one of the things that I've talked with Stefan about is, like, I'm working with another company, and when I got their product, they suggested airless, because of the bubble issue. And I did some testing with their products, and we took the air assisted airless and I shot it. Had bubbles on the surface, but they flowed out really nice. And then when I shot it with airless, there was like none on the surface. So it sounds like, from what you're saying, is that some of this could be, depending on the product. I mean, obviously it can be lots of factors. It could be, the defoamers. I'm just kind of, what I'm really trying to highlight is just bring to light that this is a complicated matter and that there's a lot of things to consider. But I'm also trying to figure out a way to help end users deal with it as well. If this doesn't work with this equipment, try this. This might work better, and so that people aren't spending thousands of dollars trying to figure out what works for the particular coating that they want to use.
Sure. Well, then let's spin it back a little bit and say one reason why people are going to make low viscosity coatings is, if the material isn't thick, that bubble, then whether it's small or large, will have pressure behind it, and it'll allow it to release through the film up to the surface. And then when it gets to the surface, it'll break and smooth out. So a lower viscosity material is going to have a lower tendency to trap air. You get some of the drawbacks where you aren't able to apply as thick a film, or you aren't able to apply as well on the sag. But certainly, if a material is thin, that air bubble is going to be able to push through to the surface, or combine with other smaller air bubbles to make a big bubble that can then break more easily. That's one aspect of having a low viscosity coating, and one way to reduce air. Another way, obviously, is increasing your atomizing air. It sounds a little odd because you're putting more air into it, but what you're actually doing is you're breaking those droplets of paint up into smaller particles, and those small particles of paint droplets don't contain the trapped air like a large, if you poured it on, and it might have that air in it as well. And to go even further than that, moving to smaller tip size will create more hydraulic pressure, and that hydraulic atomizing pressure will do the same, similar. It's a different physics behind it, but it's a similar function. It's forcing the fluid through at a higher pressure, atomizing it better, and you end up having a spray finish that has less air in it initially.
Yeah.
Also, don't shake water-based paints on a shaker.
Yeah. So you'll appreciate this. So I was in California with a company, and we were at a guy's shop, and he's like, "Hey, you want me to shake this up for you?" And I looked at him. I was like, "Boy, we're really gonna see some bubbles if you do that."
Yeah, I mean, if you shake it, let it sit for a day after you shake it.
Yeah. So that's great. Awesome. So what's and you kind of touched on this. Are there any new type of resins that you guys are excited about, that you're moving towards in the future? Are they tend to be more polyurethane acrylic, or do you guys kind of mix and match? I know there's some companies that have they're mainly polyurethane based, but they have a little bit of acrylic in them, or they're acrylic based and have a touch of polyurethane. What are you guys finding that you guys are getting excited about?
I'm getting excited about new, not exactly polyurethane dispersions.
Okay.
Dispersions based on other chemistries, just because these are things that haven't been available in the waterborne world, reasonably in the reasonable near future. We're going to see these other chemistry options brought into waterborne, whether they were something that was originally started in the solvent-borne world or something that, because it's specifically waterborne, somebody's been able to do at the resin manufacturing level. I think that's kind of what's exciting to me. We do have a pretty good breadth of both polyurethane and a few acrylics that we're using here, but we're always on the lookout for something that's it's got that little bit better, whether it's stain resistance or a little bit better early hardness. We're always open to resin manufacturers coming in and telling us what they've got that's best for us.
Really appreciate your time in doing this. I think this is going to help a lot of guys with Waterbase in general, and then some of the problems. And I'll be looking forward to maybe touching base with you on some other issues and things that come up. You seem to be willing to help out, and I appreciate that a lot.
Absolutely, yeah, no, and we work with all our customers, big guys, small guys, to make sure that they're using the product to the best, the way it's intended and the way that's going to give them the best results. So that's I love talking to customers. So
yeah, awesome. Well, thank you guys, and we'll do this again sometime soon.
All right, thanks, Eric.
Thanks, Eric.
Pleasure.